Hi everybody, this is Alex Dinham from Drayton Solutions Throughput Academy. This is the second of the efficient and unproductive videos, and in part two we're going to talk about why economic order quantities, minimum order quantities and save-in setups makes you unproductive. Before we get into the content of part two, let's just remind ourselves of what we learned in part one. We talked about the efficiency syndrome. Basically, this is the belief that the only way to make a profit is to make sure that machines and people are busy and working all the time. For most manufacturing plants, they have more capacity than market demand. So the only way that you can keep people and machines busy all the time is to release more raw material for them to work on. When I say more, what I mean is more raw material than is needed to satisfy the on-hand orders. Releasing too much inventory leads to loads of different kinds of problems. So the first of which is that it creates large queues in front of the different work centres that you have in the manufacturing plant. And if you remember, I asked you about your journey to work, and I asked you which journey would take longer, the journey when you left at 8 a.m. in the morning or the journey when you left at 3 a.m. in the morning. Most people would agree that the journey that you take and start at 3 a.m. in the morning is the shorter of the two journeys because there's less traffic on the road. Traffic means queuing means more time, and it's the same in the manufacturing plant. The bigger the queues in front of the work centres, the longer the time it takes an order to get through the plant. The longer the time it takes to get through the plant, the longer your lead time is. The longer your manufacturing lead time is, the more likely you are to have poor due date performance. Let's understand exactly why that is. The due date is a date that we forecast that the order will be able to leave the plant and ship to the customer. We give it to the customer, they start to rely on that date. But as with any forecast, the further out into the future it goes, the more unreliable it becomes. So when we have a very long manufacturing lead time, we also tend to have very poor due date performance. When our due date performance is bad, customers start to see us as unreliable. And when they do that, they often take their business elsewhere, which is obviously not great for a business that is there to make money. And the real shame of this situation is that we've done it to ourselves. The erroneous belief that everyone has to be working hard all of the time causes us to do something which actually makes performance worse. We release inventory or raw material just for people to work on to keep busy, and this is causing the problem. And one of the key things I want you to take away from this particular lesson is that inventory equals lead time. The more inventory you have in the plant, the more likely you are to have a very long lead time. Now that statement needs an important qualification later on, and I will get to it, but for now I want you to bear in mind that inventory equals queuing and queuing creates lead time. And what's the big problem with having a long lead time? Well, it makes us unproductive. Remember, our goal is to make money now and in the future. It is not to keep people busy. This isn't a job creation scheme that we're running. Our goal is to make money. And we can make more money if we're faster and better able to respond to customer demand. When we release inventory just to keep people working, we create queues, we create long lead times, and we reduce our due date performance. This is unproductive. It is not moving us towards our goal. We need to be doing things which move us towards our goal, which is looking for ways to shorten our lead time. And one of those ways in which we can do that is, first of all, to stop just releasing raw material to keep people busy. Before we get into how we might organise the manufacturing system differently, we also need to talk about some other ways in which people think that they're being efficient but is actually making them unproductive. Part 2 talks about economic order quantities, minimum order quantities and save-in setups, and how they all combine to help make you unproductive. Remember I told you last time that everything that you're hearing in video 1 is from the work of Dr. Ellie Goldratt. Same goes for part 2. And I told you a little bit about my relationship with Dr. Goldratt in part 1. I wanted just to say a couple of words about the photograph this time. There are lots of photographs of Ellie on the internet. I picked one which just happens to be black and white, but the reason I picked it is as you look at the photograph, you get a little inkling of Ellie's character. He had an amazing sense of humour, always liked to have a joke and hear a good joke. and tried to sprinkle a few of them throughout his lectures on theory of constraints and whatever he was talking about. And this picture just captured that aspect of his character for me. So there's a glint in his eye, there's a little smile on his face, and that's often how he was when he was at work and when he was teaching people the theory of constraints. Great guy. Okay, so let's get into the main part of this video, and we're going to talk about economic order quantities. And this was a concept that was created around about 1930, and as you can see by the citation there, by a chap called Ford W. Harris. It was later developed by some other guys, but the basic idea is that there is an optimal point, there is an optimal batch size which is efficient and economic to produce in the factory. So if you look at that graph there, you can see on the x-axis or the horizontal axis, you can see the batch size, and the batch size from left to right is getting bigger. And on the y-axis or the vertical axis, you can see cost per unit starting at 0 and going up as the axis goes up. Okay, so those are your axes. If you look on the right hand side, you can see that there are three little comments there. So one line represents total cost, the next one down represents carrying cost, and the bottom one says setup cost. So let's look at carrying cost first. Okay, so you can see that that line gently slopes up over time. As the batch size gets bigger, the cost per unit gets bigger, and the logic behind that is that the more inventory you have in the plant, the more carrying cost you incur. You have to handle it, you have to store it, you need space, you need machines to move it around, and so on and so forth, and that increases your cost per unit. Setup cost reduces with the batch size, so the bigger the batch, the less the setup cost. Doing a setup for a very small batch is, under this theory, very uneconomic and costs you a lot of money. If you have a very large batch, then actually the setup cost is dramatically reduced. And the economic order quantity is the sweet spot where those two lines cross. So you can see the dotted line in the middle there. It says economic order quantity at the top, and that is the optimum total cost of the batch. Now you may be looking at that total cost line and thinking, well, it dips a little bit to the right there. Alex, what's going on there? Well, it's just my inability to use keynotes, so don't worry too much about that. The basic point I need you to understand here is that economic order quantity says there's a sweet spot between cost per unit on the one hand and batch size on the other, and that's where you should set your batch size. Now, from a theory of constraints perspective, which of course is the one that we're looking from, there are some real problems with the economic order quantity concept. Is there really a cost to setups? I mean, show me the invoice that you have to pay when you set up one of your machines in your factory. When I ask my clients that question, they just look at me blankly, because of course there isn't an invoice that they receive every time they do a setup. You might use some raw materials, you might use some consumables to run in the machine, but where really is the cost of setup? Unless money actually leaves the company, we cannot claim that setups cost anything. Setting up may prevent us from producing on a given resource. In other words, it's an opportunity cost, but that's only really valid if the resource in question is a real-life bottleneck or the system's constraint. Remember, the theory of constraints says that the output of the system is determined by the constraint. If we're not setting up on the constraint, then we can't necessarily claim that there's been a drop in output. There is no real opportunity cost there, let alone a real cost. The other thing to bear in mind is real-life bottlenecks in factories are very rare. The vast majority of resources are not bottlenecks, and even when you say you've got a bottleneck, often when you look at it very closely, what you find is you've got a resource where the capacity isn't being managed properly, and it's not really a bottleneck. So where really is the cost of doing a setup? Now that's just one of the problems with the economic order quantity concept. The other more fundamental and probably more controversial to some of you is that it assumes that cost per part is a valid concept. It isn't. It isn't, and I can't stress that highly enough. Cost per part was a calculation that was created at the dawn of the Industrial Revolution. I'm going to talk more about this in another video, but fundamentally the assumptions on which that calculation are based are now no longer valid. Therefore, cost per part is not a valid concept, and therefore economic order quantities can't be, because it's based on cost per part. Okay. The other thing to bear in mind is setups are not static. They can be reduced. I worked with a group of guys up the road from here. They had an 8-hour setup on a machine. they got it down to under 15 minutes. Okay, it's not set up, it doesn't have the same cost, it doesn't imply the same thing. Okay, so watch out for the video on throughput accounting, where it will explain all of this in a lot more detail. But the point for this video is that economic order quantities is not a valid concept anymore. The assumptions on which it's based are no longer correct. Okay, so there are some real problems with the economic order quantity concept. You understand that by now, but that doesn't mean that there aren't people out there trying to use it to be more efficient and hopefully be more productive, but as a result making them unproductive. And I want to explore that topic in a lot more detail now. Now, what people tend to try and do is that they know about EOQs, but they also know that their customers rarely give them orders that are exactly corresponding to the economic order quantity. So this drives a behavior in the plant called save-in setups. Save-in setups essentially means that you group orders together that share the same setup on the particular machine that you're working on, and you try and produce them in one batch to avoid having to have another setup. So let's understand the effect of save-in setups on performance in the plant. If you look on the right hand side there, you can see that there are two columns. Just imagine you're the work center operator who has this work list in front of them. You can see on the left hand column are the priorities, so there's priority 1 through 12. And on the right hand column you can see the work center priority before save-in setup. So this is the work orders arriving to you in their natural sequence, and you can see in the box you've got work order 1 at the top with setup A in the brackets there, work order 2 with setup B, work order 3 with setup C, work order 4 with setup D, and so on for 12 work orders. Now, because you're a good work center operator and you try to follow management instruction to be efficient, you want to create economic order quantities. And the way in which you do that is to try and group together work orders that require the same setups. So you look down your work order list and you see that work order 1 requires setup A, so does work order 5, and so does work order 9. So you put them together in sequence to create one large batch, and you do the same for all of the other work orders and their respective setup. But what effect does this have on the sequence of customer orders and the way in which they get processed? Well, let's have a look. On this slide I've added another column that shows the work order sequence after the operator has tried to group together work orders requiring the same setup. So on the right hand side now you can see that work orders 1, 5 and 9 are going to be processed first as one batch, then work orders 2, 6 and 10, and then work orders 3, 7 and 11, and 4, 8 and 12. This will minimize the number of setups. In fact, I go down from 12 setups required to do the previous list to just 4 setups for this list. Now, from economic order quantity theory, this sounds ideal. I'm grouping together all of the work orders to minimize the number of setups. But let's look at it from the customer perspective. Remember, the orders came to us in the sequence in which the customers placed the orders. It's kind of like the voice of the market, actually. But now I've gone and taken those orders and grouped them into different buckets, which has pulled them out of their natural sequence. So for example, work order 2 was second in line. Now it's fourth in line. It has to wait for 3 work orders to complete before it can begin processing, when originally all it had to do was wait for 1 work order. Work order 3 was third in line. It's now 7th in line and has to wait considerably longer before processing can begin. Work order 9 is now third in line, so it's jumped up the queue, so we're actually producing something too soon. Okay, remember, the work orders were released in line with market demand. Save-in setups may be efficient for the work center, but it is deviated from market demand. If I'm now a customer who has to wait longer for my work order as a result of you save-in setups, that's not a good thing. Also, bear in mind that this is just one work center in the factory. There are others. It is unlikely that grouping the work orders in this particular priority list will work for all of the other work centers. So they're going to do their thing as well. They're going to take the orders, take them out of sequence and group them together to save setups and make economic order quantities as well. So the priorities are going to change all the way through the factory. Saving setups to try and create economic order quantities takes orders out of their natural sequence. It prioritizes local efficiency over the global optima. Confirmed customer orders are being delayed, lead times extended, and due date performance is being reduced. It ties up cash longer than is necessary in inventory. It damages our reputation with customers when we deliver late. Remember, we work in a competitive environment. Customers have choice. They can go elsewhere. If we fail to deliver on time this time, there might not be a next time. If you'd like to explore how big batches impact on your lead time, I strongly suggest you play the batch game. Get 3 or 4 people together from your company and take a piece of paper and tear it up into 8 equal pieces. Now, the rules of the game are you've got a little production sequence of 4 people, say. The first person has to sign all 8 pieces of paper before they hand over the batch of 8 work orders to the next person. The second person does the same thing. They sign all 8 pieces of paper before handing it on to the third person. The third person signs all the pieces before handing on to the fourth person, and then the fourth person signs all 8 pieces of paper. Time how long that takes, from the first signature of the first person to the last signature of the last person. So now you've made a note of the time for run 1, it's time to do run 2. This time we're going to operate in a small batch environment. What that means is that each person in the process, when they sign one piece of paper, can immediately hand it on to the next person who can immediately begin work on it. No saving up batches of 8 pieces of paper. Sign one piece of paper, hand it on, the next person can get on with it. You can continue to sign the pieces of paper that are still at your work center. You're going to time from the first signature to the very last signature, just like last time, and we're going to check for the difference in the lead time. Now it's time to compare the times. Run 2 is usually significantly shorter than run 1. Now, why is that? It's due to the fact that a lot of the time that the batch is in process in run 1, the pieces of paper are either waiting to be processed or waiting for the other pieces of paper in the batch to catch them up. So for example, you start the process, the first person signs a piece of paper, puts it to their left hand side, and that piece of paper then waits for the other 7 pieces of paper to catch it up. Only then can the batch move on to the second person and the process is repeated before moving on to the third and so on. Run 2 is different. We work in parallel in run 2. As one person is signing the first piece of paper, they immediately hand on, the second person immediately starts. There's no waiting for the other 7 pieces of paper to catch up. Big batches create long lead times. You can see that from run 1. Imagine now a manufacturing plant with multiple work orders with multiple big batches going through simultaneously, and it doesn't take any large stretch of the imagination to see why that can result in such a long lead time relative to the actual processing time required. Contrast this with run 2. In run 2 we make a distinction between the process batch, which is the total quantity of work, and the transfer batch, which is the batch that we move through the factory. In our case, the process batch is 8 units or 8 pieces of paper, and the transfer batch is 1 unit or 1 piece of paper. Moving the batches through the plant in small transfer batches of 1 in this case enables the work centres to work in parallel and therefore reduces the total time, elapsed time, that the whole of the process batch is actually in the manufacturing plant. Now in reality, many times the process batch is often equal to the customer order, and the transfer batch would be a smaller subdivision of that process batch. It depends on the environment, it depends on the number of units in the order, it depends on some other factors as well in different environments, but that's the general principle. The process batch is bigger than the transfer batch, but they may all actually be going to the same customer. The effect of making the distinction between the process batch and the transfer batch is really evident in the batch game. The time difference is often dramatic, and if you extrapolate that to the plant, you can see a reduction in lead times and an improvement in due date performance. Remember, the due date, as I've said several times before, is a forecast. The further out the forecast, the more unreliable it becomes. If you bring your lead time in, your due date becomes more and more reliable. You start to hit it more and more often, and the customers notice very quickly. MOQs are just an extension of EOQs. MOQ stands for minimum order quantity, and what we do here is we use a policy that tries to force our customers to purchase in quantities that are equal to or getting towards at least our economic order quantities. Now, this is not a wise thing to do, particularly when the market is your constraint, because anything that you do to put customers off from buying from you when they have multiple other options to go to in the market is less than wise, let's put it that way. How your customer responds to your MOQs really depends on the specifics of this situation, but let me just tell you a little story from real life experience. I used to work with a packaging company that made boxes for consumer goods, so they were corrugated card with a printed outside which was colourful and bright and so on, and help with point of sale promotion. This company tried to impose on its customers a minimum order quantity of about 3,000 units, and the customer was much bigger than them and accounted for a very large portion of their work, and they just turned around and said no. They said, no, we're not doing that. We need 1,000 units, take it or leave it. So the packaging company had to take the order, but what they then did was release the raw material required to make the whole minimum order quantity. So for example, 3,000 units instead of just the 1,000 that was needed to satisfy the customer order. It then shipped the 1,000 units to the customer and then took the remaining 2,000 units, put them on a lorry and then sent them to a warehouse where they then sat on a shelf. Now the idea was that the customer would inevitably come back and reorder that particular box, and therefore they could take some from the 2,000 boxes that were on the shelf and sell them to the customer without having to manufacture. And of course their manufacturing would have been really efficient because they would have made according to the minimum order quantity of 3,000. Nice in theory, not so great in practice, because then what would happen was that the customer would then decide to have a promotion, and the promotion would necessitate a change to the printing on the outside of the box. It would say 2 for 1 or a price reduction or some kind of graphic or whatever it was, but it would mean that the boxes that had been printed in anticipation of the customer coming back and ordering them later on were now obsolete. They couldn't use those boxes. So the customer would come along and say, we want this number of boxes with a new design, and the company would have to produce those boxes and probably produce more than the customer really wanted because of their minimum order quantities, but it would then also have to go back and scrap the boxes that were sat in the warehouse. And in order to do that, they had to pay a transportation company to go and collect the boxes, to take them off the shelf, to transport them to where they were going to be scrapped or recycled. So what happened next? Well, the packaging company started to learn about the theory of constraints, and one of the things that they cottoned onto was that this idea of minimum order quantities and economic order quantities was in fact crazy stuff. So they stopped releasing work into the plant over and above the customer order. They just started to produce to the customer order. So down from say 3,000 units to 1,000 units, and then they just shipped the whole lot to the customer. Within 6 months, inventories had dropped dramatically because they were no longer storing excess inventory in warehouses. OE dropped dramatically because they were no longer having to pay for that stock to be stored in somebody else's warehouse. They were no longer having to pay for transportation companies to move that stock around, and it obviously freed up significant amounts of capacity in the plant that they could then go and sell elsewhere. Within 6 months, they recorded their best year to date. What's the moral of the story? Well, the moral of the story for me is you're trying to do something, in this case, follow minimum order quantities to generate economic order quantities, which you think is the right thing to do because it makes you efficient. But it does the opposite. Actually, what you do is store up all kinds of problems elsewhere in your system, your company as a whole, from just trying to optimize local performance on one particular machine in their case, which was the press. And actually what this did was cause all sorts of problems further down the production line and to the financial performance of the company as a result. Being efficient makes you unproductive. Let's just remind ourselves of the exact mechanism by which longer lead times equal lower sales. Look at the little throughput style profit and loss table on the slide there. You can see that we've got sales, raw material, throughput, operating expense and net profit. If everything was shipped as it should be shipped in this period, then the numbers would look like they are in the first column there, which says invoiced in this period. Sales of 100, raw material of 40, throughput of 60, operating expense of 50 and net profit of 10. What tends to happen when you've got longer lead times than necessary is that orders which should be shipped in this period start to be shipped in the next period. So for example, if you had an order which was due to be shipped on the, let's say, the 28th of the month, and it's late because of the efficiency syndrome, which is causing queuing in the plant, and then you've got people trying to create economic order quantities and save setups on the work centers. The lead time inflates, and then instead of being shipped on the 28th, it goes on the 1st or the 2nd of the month. What this means is that instead of invoicing for sales of 100 in the period, you actually only invoice for 90. Now, if you're lucky, you won't yet have paid for the raw material that you've used, in which case your raw materials will also be lower, but it could well be the case that you actually have to pay for your raw materials as well. Let's just look at the middle column there where it says invoice next period. So instead of sales being 100, they're actually 90. Raw materials might be 36 instead of 40, so your throughput goes to 54. Your operating expense stays the same. Remember, in most manufacturing environments, the majority of costs these days are fixed. They may be classified in the accounts as variable, things like direct labour and so forth, but actually you still pay a 1/12 of the salary each month for the people who are doing the work on the shop floor, the direct labour. They don't vary. Those people could take 2 weeks off, or they could be in work every day during the month. They still get paid the same amount. So when you don't ship as much as you plan to ship and you don't invoice as much as a result, your costs largely stay the same, but your sales are down, and this is what accounts for the reduction in net profit. If you're really unlucky and you've had to pay for your raw materials up front, or before you've managed to invoice the client for the order, then actually your net profit is going to be even lower than that at 0. So a quick reminder there of the direct channel by which long lead times and poor due date performance directly reduce sales and net profit. If you suffer from the efficiency syndrome and you're trying to keep people and machines busy all of the time, you have to release inventory above the level required to meet on-hand orders. This inevitably means your lead times will be longer than they need to be because of the extra queuing in the plant, and most likely your due date performance will be lower than it should be. This is going to make you unreliable in the eyes of the customer. It will also lead you to invoicing later than you otherwise could. If you combine the efficiency syndrome with economic order quantities and saving setups, then your lead times get even longer and your due date performance worse. Remember, when you're saving setups, you're effectively selecting different orders from the queue in front of you and combining them to create larger batches so that you have to do less setups. This cherry picking means that orders which are ahead of the queue in terms of market demand get left behind. Orders which possibly don't even have a customer order against them jump ahead of those orders and get processed first, and therefore get selected or stand more chance of being selected on the next work centre first as well. And here's the important thing. As orders are delayed in the factory, those delays get then passed on and accumulate as the work order progresses through the factory. There is no catching up. Once you've lost time, it's lost forever. Remember, our goal is to make more money now and in the future. Actions which move us towards that goal are productive. Actions which move us away from that goal are unproductive. Trying to optimize the efficiency of individual local resources does not optimize the production system as a whole. In fact, it takes us away from that and actually costs us money, particularly in the case of the packaging company that I just talked about. So we have to find a different way. Remember, the constraint of the system determines its output and its performance. Economic order quantities, minimum order quantities, saving setups do not help. Big batches increase inventories and lead times. They disrupt flow through the system. And remember, inventory equals lead time. And when the lead time starts to increase, due date performance starts to go down. These actions cannot be claimed to be productive. They are taking us away from our goal. Okay, that's almost it for part two. As with each of these videos, I'm going to recommend a little bit of reading for those of you who really want to get under the skin of this topic. This time it's The Race by Goldratt and Fox. Last time we had The Goal by Goldratt and Cox. This time we've got The Race by Goldratt and Fox. That's not a typo. Bob Fox was one of Ellie's partners at one point. The book is very interesting. It comes in a slide and commentary format. So on the right hand side you've got a slide or a graphic, and on the left hand side you've got some prose text which explains what you're seeing on the graphic. It really explains in detail the relationship between inventory and performance, so highly recommended for those of you who are very serious about understanding theory of constraints knowledge on manufacturing. There's also some really nice puzzles at the end to really test whether or not you've understood what you've read and you are starting to make the paradigm shift into the throughput world, if you like, which is what some practitioners describe a deep understanding of the theory of constraints to be. So highly recommended, obscure little book, but one that's very valuable. Okay, that's it for part two of Efficient and Unproductive. Thanks everyone for listening. I hope you found it helpful. As ever, feel free to get in contact. Details on the next slide. Drop us an email or a tweet or something like that. If you have a comment or a question, I'll be happy to get back to you. And thanks very much for listening.